In lesson 6.1, we're going to be starting circles and specifically talking about properties of these circles. So the first thing that you need to know is that in a circle we have something called a central angle, and that central angle has its vertex at the center of the circle. So for example, in the picture that you see on the top left, the center of our circle A is A, and you'll notice that the angle ABC is intercepting an arc called BC. So as I look at that arc, the thing that I'm talking about is this arc right here, BC. So it's a part of the circumference of that circle. The central angle, A, that we were talking about, is this angle right here in the green. And again, it has its vertex at the center of the circle. Also, in the second picture, we have something called an inscribed angle. It is a little bit different than a central angle, as it has its vertex on the circle, not at the center, but on the circle, and its sides are two chords, meaning that they are segments that connect one part of the circle to the other. So this inscribed angle is called EDG, and you can see it. It's right here in the pink arc that I made, and it intercepts arc EG, and we're going to talk about some of the properties of this a little bit later. So first of all, on this slide, a central angle has its vertex at the center, and second of all, an inscribed angle has its vertex on the circle. If you know that you have two chords in a circle being congruent, that means that the central angles which they are connected with are also congruent. So for example, as we look at this particular picture here, we see chord BC and chord PQ, and if I know that these two chords are congruent to each other, that means that I also know that angle CAB, so angle CAB, is congruent to angle PAQ. So two congruent chords determine two congruent central angles, and the interesting thing is the converse is also true, that two central angles determine two congruent chords. So you can say it either way. If we know two chords are congruent in a circle, then the central angles that they are associated with are also congruent. Or you can say if two central angles are congruent, then the chords that they are associated with are also congruent. The last thing in this section that we're going to talk about is the perpendicular bisector of a chord. The perpendicular bisector of a chord passes through the center of the circle. So if I know that the perpendicular bisector in this case happens to be AB, and it is the perpendicular bisector of the segment DE, meaning that from C to E and C to D are the same size, and that we have a right angle. So AB is the perpendicular bisector because from my markings I know there's a right angle at the intersection, and also that the two pieces created by that orange AB chord going through the blue DE chord create two equal pieces, CE and CD. Then I also know that that perpendicular bisector in orange, called AB, will also pass through the center of the circle, called C. So if we have a perpendicular bisector AB of a chord DE, then I also know that that perpendicular bisector AB is passing through the center of this circle C.